Okay guys, so in this video we're going to be talking about arithmetic sequences, and I went over arithmetic sequences in one of the other videos, what they were. Basically, arithmetic sequence is a pattern in which you're adding and subtracting something the same constant number or the common difference every single time. So today we're going to be looking at arithmetic sequences, a little more complicated version of them. We're going to be using the explicit formula for arithmetic sequences. And what that is, it says that Fn equals f1 plus d parentheses n minus 1. So what this is saying is that any term that lands in order n, so Fn, is equal to the first term in the sequence plus the common difference multiplied by the order number, which is whatever order, first, second, third, fourth, fifth term, right, minus 1. So Fn equals f1 plus d parentheses n minus 1, so multiply by n minus 1. We're going to be doing some examples and solving for each one of these things, and so you guys can see how they give you these problems in terms of solving for the unknowns using the formula. So let's say they give you this pattern, right? So we have a pattern. The pattern is 79, 75, 71, 67, 63. So we're actually subtracting by something every single time. We are not really sure what, so let's see what it is. So to get from one number to the next, it looks like we are subtracting 4. Yeah, so hopefully you guys got that right. So d is equal to 4. We're subtracting 4, so I'm going to write negative 4. So right away, I know one of my unknowns in the formula, so I know that d is equal to negative 4. What other things do we know? Well, we know the first term. So if you remember, f1 is something that we need for the formula. f1 is the first term, or the first number in the pattern. f1 is equal to the first number is 79 in this case. Very first number you see is 79. Okay, and then the last thing we need to figure out a term. So the term number. So it says find the 32nd term. So they kind of implicitly tell you that n is equal to 32. Now, we could find the 32nd term without using the formula. We could do that. We could do 79, and that's our first one, right? And then subtract 4, that's our second one. Subtract 4, that's our third one. Subtract 4, that's our fourth one. Subtract 4, that's our fifth one. And then I keep doing that over and over and over and over again until I get to the 32nd one, and then that'll be my answer. Do you want to do that? Maybe not, because that'll be a waste of precious time, especially if instead of 32nd term, what do they say, the 32nd thousandth term or 3 millionth term or something crazy like that. You're going to be there all day subtracting, and even if you use a calculator, it's going to take you a long time. So don't even bother doing that. Plug it into the calculator. It'll make your life so much easier. So if you plug it in and use the formula, we get that the 32nd term, so I'm going to write it out as f32 is equal to f1, which is 79, plus the common difference, which happens to be negative 4, multiplied by n, which is 32, minus 1. So just so we're clear about where I got all these numbers from, 32 was the n, right? So that's the n that they give me. D was the common difference, so I plugged it into there, and I got negative 4. So everything is from the formula. And then lastly, f1 is the first term, which in this case, they tell me that the first term is equal to 79 from the pattern. So I plug in 79 into that. All we have to do is simplify, and then we're done. So instead of subtracting negative 4 over and over and over again, this formula tells us that it's going to be equal to 79 minus 4 multiplied by 32 minus 1 is 31. So 4 multiplied by 31, that gives me 124 negatives. So this becomes 79 minus 124. And then if we subtract 79 minus 124, we get 45. So my final answer would be equal to negative 45. And look, I did that in not that much time. So if we subtract 4 over and over and over again, my 32nd number that pops up is negative 45. Okay, so that is solving for a term. Now let's do an example about solving for the order of a term. So in this case, we're solving for n. And then we'll do another example in which we're solving for d. So let's do this one. Example number 2, solving for the order of a term. So using the formula and the order number of the term, using the formula, find the order number of the term negative 4 in the sequence. Now I give you this pattern and this sequence because I know you guys can do it without using the formula just by looking at it. So what is the order for the number -4? Well, if we notice the first one is 8, second one is 5, third one is 2, fourth one is -1, and the fifth one is -4. So the answer should actually be, without doing any work, n equals 5, because the answer is that, well, the fifth one is -4. But now, what if they give you something crazy, like a different number they wouldn't be able to verify? I want you to know how to use the formula for that reason. So let's plug in what we know. We're going to plug in, let's see. So we're going to plug in F1, the first number in the pattern. We have to figure out our common difference, what it is that we're subtracting or adding each time. And then we also have the number that they give us, or Fn, which happens to be -4 in this case. So first of all, what is our common difference? So it looks like we're subtracting 3. So I'm going to write d equals -3. So we have our difference. That's going to go in here. We also need our first term of the pattern. The first term of the pattern happens to be 8, so that's going to go in there. And the only other thing we need is not n, right? Because that's what I'm solving for. I'm actually going to be needing to use the actual number that they want. So term -4 would actually go right in there. I'm going to try to make it different by boxing it. So the actual number that they give you would go for f of n. So I'm going to plug it in as -4, which is f of n, is equal to f1, which is the first number, which happens to be 8, plus the common difference, which is -3. So I'm going to write a negative in front, multiplied by n minus 1. Notice I don't have anything for n because that's the one that I'm solving for. So I know what my answer should be, right? I'm just going to verify it real quick. So in this case, let's simplify and solve. So -4 is equal to 8. I'm going to use the distributive property here. -3n plus 3. Combine like terms, so that 8 can be combined with the 11. So -4 is equal to -3n plus 11. And then draw the wall, subtract 11 on both sides. We get -15 is equal to -3n. Divide by -3 on both sides. And what do you know? We get n is equal to 5. So what this tells me is that the order of term number -4 in this pattern is equal to the fifth one. Now, notice that, again, for this particular problem, it's not that useful, but if you get another problem in which they want to figure out an n for, like, let's say they tell you -1 million or -1 billion, instead of you having to do this and try to count the order, forget that. Use the formula, solve for n. Okay, last thing they might have us do is something like this, like example number 3. What is the common difference between the sequence of numbers when the first number is 0 and the seventh number is 48? So I kind of laid it out for you guys here so you can see what it is that they're asking. So the first number is 0 and the seventh number is 48, and they don't give you anything in between. What is the common difference? So what is d? So in this case, we're solving for d. Notice that I know f1. Notice that I also know the number 48. So I know this guy and I know this guy. So I'm going to go ahead and just plug in what I know. So 48 is fn, right? That's the number that I know. And the first one that I know, first number in the pattern is 0. So I'm going to plug that into there. I have no idea what d is. So I'm going to put plus d. I don't know what it is. And I kind of implicitly know n. They don't tell me what n is, but if you notice, this is the first number, right? So that's f1. N is the number that belongs through the term. So this term, the 48 that I'm talking about here, let's figure out the order of that number. So this is the first one, second, third, fourth, fifth, sixth, seventh. So n has to be equal to 7 implicitly, or the number inside the parentheses would be equal to n. So this will be 7 minus 1. Okay? So make sure you understand where these numbers came from. If you don't, ask questions, please, so you can understand later when you're in class. And yeah, all you have to do now is solve for d. So we get 48 is equal to d times 6, right? 7 minus 1 is 6. So I'm going to write it as d parentheses 6. I want to solve for d, so I'm going to divide by 6 on both sides. And I get that 8 equals d, or d equals 8. So what does this tell me? Well, this tells me that the common difference is equal to 8. So let's say, for example, the problem was saying, hey, you got to fill in the rest of the boxes here, or the rest of the blanks. Then you could do that, right? So 0, and then the next one should be 0 plus 8 because it's positive. So that would be 8 16, 24, 32, 40, and then the last one should be 48. And if you check it, it actually does match up with our pattern. So you know you got it right. Okay, hopefully this video was helpful. Good luck, and I'll see you guys later on.